Product, quotient, and chain rules. And really what I want to do is just give you a feeling for what can these problems be like from relatively simple, not the very simplest thing you're going to see, but something that requires a little bit of work, to something that's really just long and laborious. And I highly encourage you to, at each question, just go ahead and pause it and try it on your own and see how far you get. And you can catch back up and see if you were doing things correctly. Also at the bottom there, you can see links to each of these problems individually, so you can jump right to the one that is the most appropriate for your level. All right, with that, let's get started. So let's get started with the first one. So as I said, I don't feel like this is a super easy problem, but it's also not going to be too many steps. This is a good starting point if you've sort of seen the basics already. So what we've got here is x times e to the x on top of the fraction, and then on the bottom, just sine x. So one of the things I hear a lot from students that have trouble with getting past the very simplest product and chain and quotient rule questions is, so here I've got multiplying, so maybe it's the product rule, but I've also got dividing, so maybe it's the quotient rule. So how do I know which one to do? So I think the easiest way to think about this is you want to take the entire problem and view it as either being multiplying or dividing, or in the case of chain rule, which we'll get into more later, one function stuck inside of another one. So here, yes, I see some multiplying, but in my mind, the easiest way to think of this as one thing is I've got something on top divided by something on bottom. So in that case, it's a quotient rule. So note that on top you see the multiplying, but it's just one little bit times one other little bit. The bottom is not part of the problem. So with that, let's go ahead and get started. So what we're going to do is, since we're using this as the quotient rule, what I like to do at each step is just go ahead and write out what you're going to be doing without trying to take the derivatives in your head. So the quotient rule says start with the bottom one. So I'll go ahead and leave that alone. Times the derivative of the top one. And here's where I said I'm going to be writing the derivative different ways. I like to write it this way because then I can just leave it like this and just say, look, it's the derivative of the top. I'm not going to worry about what that is yet. I'm just going to leave it that way. So we did bottom times the derivative of the top minus the top times the derivative of the bottom. Again, maybe you could just do that in your head, but for right now, I'm going to go ahead and leave it this way. Also, I'm using square brackets here. That doesn't mean anything different. I think it's just nice to not have too many parentheses floating around. Divided by the bottom squared. Okay, so there we go. All right, so with that, let's go ahead and see what we've got to do. So the first part, we've just got a sine x. I don't need to do anything with that. The next part, I've got derivative of x times e to the x. Okay, that's some work I have to do. Then I've got x times e to the x. That's just fine. And then finally, I've got derivative of sine. So if you don't already, I highly suggest just go ahead as you're going through these problems, and really all practice problems for derivatives, keep a list of common derivatives next to you. It really makes life a lot easier later. Okay. So a really good trick is on the side of your paper, take an area that's just for scratch work or a whole nother piece of paper. I'm just going to go ahead and put it off to the side here, my scratch work. And for my scratch work, I'm going to go ahead and do the derivative there. So I've got the derivative of x times e to the x. Okay, so this is the product rule. I've got one thing multiplied by another thing. So let's go ahead and just work it out. So it's the first times the derivative of the second. Again, I'm not going to even take the derivative. I'm just going to write it out. Plus the second times derivative of the first. Okay, now let's go ahead and do that. X is just x, of course. Again, from your sheet of common derivatives, derivative of e to the x is e to the x. And the e to the x stays by itself. And the derivative of x to the 1 power is just 1. So of course we can clean that up a little bit. That's x times e to the x plus e to the x. Okay, great. So we've done really all the hard work now for this problem. So let's just go ahead and start plugging it back in. So what we see is we've got sine x times the derivative of x times e to the x, which we just did off to the side. And so we'll go ahead and just copy that in there. And then minus x times e to the x. The derivative of sine x, again, just from your common derivative sheet, you'll have that is cosine. And all on the bottom there, we've still just got the sine squared. Note that you can write it with the square outside the parenthesis there. I don't really like having so many extra parentheses, so I'll write on the inside. That's exactly the same thing. And then at that point, you're done. So I know a really common question I would get when I teach calculus is, how do I know if I'm done? How do I know, is this a good enough answer? Do I need to simplify more? And really, that's going to be different by every teacher, every professor, so I can't answer for everyone. But I know, at least for me, the thing I look for is there anything really simple left over? Is there something like a sine x plus sine x you could simplify, or an x divided by x? So here, I don't see anything immediately obvious as real simple, but maybe, if I was doing this on a test, say, I would go ahead and also distribute just so that I can easily see for myself if there's anything left over. So I distribute in the sine x, and it looks like that for theirs. The second part there's nothing I can do, so that I'm going to leave alone. And on the bottom, I've got sine squared. So let's see here. Do I have anything I can combine? Well, I've got the x times e to the x, but no, one's got a sine, one's got a cosine. It kind of looks like that's it. So there we go. Depending on how your professor or teacher wants it, I think either of these are really great answers. Okay, so there we go. So that's a pretty straightforward derivative practice problem using both the product rule and the quotient rule. So let's go on to something a little bit more complicated. Okay, so here we've got a cosine on the outside, and then inside of it we've plugged in natural log of x times x squared. And I picked this one for two reasons. One is that I know that for most students, chain rule is simply harder than the product rule or the quotient rule. The rule itself is kind of weird looking. I totally get why it's harder. The second thing is I know a lot of people don't like dealing with logs. So I just want to do one with this to show you logs are actually very much your friend. They're really not hard at all to deal with. Okay, so again, when I'm looking at this, I'm trying to decide, am I using product rule, quotient rule, chain rule? Yes, I see some multiplying, but it's not the whole problem is multiplying. The multiplying is just inside of something else. But I do see I've got something on the outside, cosine, and I've got some stuff on the inside, natural log x times x squared. So we're going to go ahead and use the chain rule then. So remember, if you go back, jump back to the slide there or look at your notes, the chain rule says, okay, I'm going to start out by taking the derivative of the inside. So again, I don't want to try to do this in my head. Let's just write it out. So I know from experience that by far the most common issue that students have is they try to do too much in their head. They don't write things out. So just write it out there. Okay, now here I'm going to actually break my own rule. The one time when I do really think it's good to do things in your head is in the chain rule. And it's simply because trying to write it can actually make things be much more confusing. So the chain rule says, take the derivative of the inside, okay, I've written that out, times, now take the outside function and take its derivative. So I'm going to do that actually in my head because typically it's pretty easy. Cosine, the derivative of cosine is negative sine. I'm going to go ahead and put the negative out in front here because otherwise if I stuck the negative in the middle, it would look like it's subtraction, but it's not. Okay, so times, that becomes a sine. And you take the old inside and you plug it back in. If you'd like a video just about the chain rule, maybe leave a comment below and let me know, and I'll go ahead and put one of those together. Okay, so looking at this again here, what we see is really now, there's only one thing left to do. It's just the derivative of natural log x times x squared. Nothing else has any derivatives left. So again, let's go ahead and take our scratch work here. Either take another piece of paper, or if you were doing it on an exam, I would go ahead and do something just like this, write scratch work so that the teacher or professor understands, hey, this is where I'm just doing some side work here. And let's go ahead and compute that. So I'm going to compute the derivative of natural log x times x squared. Okay, so again, this is clearly multiplying. One thing times the derivative of the other. So I'm going to use the product rule. So product rule says take the first one, do nothing, times the derivative of the second one, plus just do the opposite now. So I take the second one, do nothing, times derivative of the first. Okay. So these two derivatives are pretty straightforward. Here I've got derivative of x squared, that's 2x. Again, I like to leave numbers in front. So we'll go ahead and write it like this. And then here, derivative of natural log, again, maybe you don't have that memorized, but you can look at your sheet of derivatives and see that it's 1 over x. So here's an example where I would potentially penalize someone if they didn't do this next step. See, what I can see here is I've got an x squared on top and I've got an x on bottom. Another way to write that would be to go ahead and just multiply the fractions to make it be x squared over x. So now we can see you can do some simplifying there, right? So let's go ahead and do that. So you've got the two x's on top, and you've got a single x on bottom. That just becomes x. Okay, good. So let's go ahead and plug that in now. We're basically done with the problem. So we have the negative out front. Remember, the negative came from taking derivative of cosine is negative sine. And now we just got the derivative and found that it was this big old guy. It's 2x times natural log x plus x. And I really just like using parentheses to avoid getting a negative in the wrong place or not multiplying everything together. And then the sign, just go ahead and stays right there. Okay. So at this point, let's do a quick check to see, okay, is there any common, easy stuff I can combine? And I've got an x and an x, but no, one's got a 2 natural log x, the other doesn't. Same thing on the inside, so that's it. So we can see here having a chain rule and having the logs actually was not a big deal at all. It was a very, very short problem. Okay, with that, let's go on and get to something a little more complicated. Okay, so here we've got a square root on the outside, then on the inside we've got x squared plus 2x plus 1 over e to the x plus 1. So I really like problems like this, and when I teach, I really like giving problems like this. And I'm going to explain why. So a lot of students will go ahead and just say, okay, let's see, I've got a square root on the outside. That means I'm going to do a chain rule. Then when I'm taking the derivative of the inside, I'm dividing, so I'm going to do a quotient rule. Okay, so let's just get started. And that will definitely work. You can definitely do a chain rule followed by a quotient rule. But if you stop and you think about it a little bit, you can save yourself a ton of time. So something I highly encourage people to always do is when you get a problem, first see, can I do anything to simplify it? Can I do anything to clean it up? Okay, so what I do see is on top, x squared plus 2x plus 1, that's the kind of thing you've been factoring probably for years. So let's see here. So can I do any factoring there? So that's, so here, multiply to 1, add up to 2. That makes it be x plus 1 times x plus 1. Okay, well, x plus 1 times x plus 1, that's the same thing on top. So I can go ahead and rewrite that as x plus 1 squared. And now, well, remember when you're square rooting something, like for example, if you were square rooting something like 4 over 9, what you would do is you would square root 4 on the top and you would square root 9 on the bottom to get 2/3. Well, so it's the same thing here. What I'll do is I'll go ahead and give the square root to the top. Maybe you're already kind of jumping ahead of me here and seeing where we're heading. And I'm going to give the square root to the bottom. So now what I see is, hey, on top, I've got a square root and a square. So those two things can cancel each other out. So on the top, I've just got x plus 1. And on the bottom, I've got root e to the x plus 1. So the nice thing is now you've just made your problem simpler. Would it have been wrong if you didn't do this? No, of course not. But hopefully by doing it this way, you can make life a little easier later. So let's go ahead and use that and take the derivative of that instead. Okay, so starting this, now the thing that I kind of like is we no longer have that big square root totally on the outside. So I see this as being a quotient rule. I've got something on top and something on bottom. So let's go ahead and do it that way. So for quotient rule, I leave the bottom alone first, times derivative of the top. Again, this is probably something you can do in your head, but I'll go ahead and write it out here just to be clear. Minus the top, again, parentheses are your friend, times derivative of the bottom. So right now I'm already seeing this is probably going to be the part that's going to be some real work in this problem. Okay, divided by the bottom squared, so the bottom and squared. And you're probably already seeing, hey, that's pretty nice. I got a square and a square root. Those two things are going to cancel each other out. So I think before we deal with this big ugly guy here, let's just write out the easy stuff. So the first part, e to the x plus 1, that's great. Derivative of x plus 1, remember derivative of x is 1. Derivative of 1 is 0, so this is just times 1, so it doesn't really do anything. Minus x plus 1. And again, I don't look at this and just immediately see a nice simple answer popping out. So if that's the case, just copy it down and we'll do it in our scratch work. On the bottom, the square and the square root are going to cancel each other out. So that gives us something pretty nice there. Okay, so I really like with something like this, you see this big ugly derivative really is just doing one simple derivative. Square root of e to the x plus 1. And maybe that's not super simple, but it's much easier than what we started with. So let's go ahead and move to a fresh piece of scratch paper and start trying this. Okay, so the first thing that's really helpful when you're taking derivatives with square roots is don't leave them as square roots. Make them instead be 1/2 powers. And the reason for that is that it's just you already know how to take the derivative when you've got powers. Right? That was probably one of the first derivatives you learned. Probably what you learned is the power falls down in front and then becomes one smaller up top. You subtract 1. So that's what we've got here, right? We've got a chain rule. On the outside, we've either got a square root or a 1/2 power, however you want to think about it. On the inside, we've got e to the x plus 1. Okay, so let's go ahead and do that. So remember, for the chain rule, the way we do this, take the derivative of the inside. Again, maybe you can do this in your head, but I'll just write it out right here. Times, remember here's the place I said I like to break my own rule. The derivative of the outside, so the 1/2 power. So I know for a 1/2 power, the 1/2 falls in front, and then I subtract 1 from it, right? 1/2 minus 1 is negative 1/2. And then the inside stays exactly the same. Okay, let's go ahead and do this derivative now. So derivative of e to the x is just e to the x, and derivative of 1 is nothing, 0. So I'll just go ahead and write that there right now. And the rest of this didn't have any derivatives, so there you go. And now I'm just going to go and do a little bit of cleanup there. So I like to have the numbers in front. We'll go ahead and put my e to the x plus 0. And I'm actually going to leave this as the negative 1/2 power. Again, I actually think in so much of calculus, it is so much simpler to think of roots as powers. So that's how I'm going to leave it. Okay, so there we go. We've done the hard part of the problem. Let's go ahead and bring this back over to the other side and see where that leaves us. Okay, so what I'm going to do, I'm going to go ahead and substitute in now that value for what we just got from our scratch work for the derivative of square root of e to the x plus 1. Okay, so at that point, that's it, right? There's nothing else to do. We've done all the derivatives. So again, you might look through and see if you can do any cleanup here. Like I see that we've got times 1. Obviously, doing times 1 doesn't do anything, but really that's kind of it. So at this point, I'll do some really basic cleanup. We've got e to the x plus 1. I got a 1/2 here. I kind of like to go ahead and just pull the numbers out front, but again, that's probably not something that's going to cost you points or anything like that. So at that point, I think really we can call it a day here and say that we have done just about everything that we can. And with that, let's go ahead and move on to the last problem. So if you're this far in the video, you're probably saying, okay, this is definitely a quotient rule, right? I'm dividing two things. So let's go ahead and start doing it. So we do the bottom times the derivative of the top. We're definitely not going to be doing that in our head. So I'm just going to go ahead and copy that down here. And this is a place where you already have to start being careful with things like your parentheses. So just count them if you really need to. Okay, so bottom derivative of the top minus the top. And this is all going to be times the derivative of the bottom. So again, do yourself a big favor by just being careful and patient and not trying to do too much at once. So even in this really simple thing like derivative of cosine, I'm just going to put it there just so I don't forget it later. Okay, divided by the bottom squared. Okay, so looking at this, I see, again, there's really only one hard thing to do here, right? I've got a cosine, cosine's fine. Then I've got this big derivative. That's going to be some work. Then after that, yeah, I've got a big ugly sine, but I'm not taking the derivative. It's just sitting there. And derivative of cosine, okay, that I can do in my head. And on the bottom, cosine squared. So let's go ahead and jump right to scratch work and start working on this big, ugly derivative. So let's get to a fresh piece of paper here. So the first thing you may see when you look at this is you may say, okay, I've got sine on the outside, and then I've got this stuff on the inside. And that's sort of true, but you don't just have sine, right? You have sine to the fifth. So really, right, another way to write this would be, okay, I have the derivative, and inside of a big ol' fifth power, I've got sine of x plus ln of sine x. So really, right, that is our chain rule there. I've got the fifth power on the outside. So let's go ahead and start doing that. So to do this, I need to take the derivative of the stuff on the inside. So, okay, the stuff on the inside is sine of x plus ln of sine of x. And then I take the derivative of the outside thing, right? The outside thing is a fifth power, so the 5 falls down in front and then becomes a fourth power. And the inside stuff just gets copied in. That's always the nice part of the chain rule. You just get to copy in what was in there before. Okay, so at that point, what we can do now is say, okay, again, right, I've got this derivative I need to take of this ugly sine. Well, what else are we going to do, right? You get out the next step of your scratch paper and you do it again. So let's go ahead and do that. Okay, so you can see what we're doing is we're kind of slowly peeling away more and more layers of this. So again, okay, we've got a sine on the outside, we've got stuff on the inside. This is definitely a chain rule. So if we do that, we're going to take the derivative of the stuff on the inside. So that's x plus ln of sine x. And at that point, we then take the derivative for the thing on the outside. Derivative of sine is cosine. And we plug back in the old stuff. So if you're already this far in, I'm going to go ahead and do a little bit in our heads here rather than writing everything out. For something like a test, I probably wouldn't recommend that. But if you're working on your homework, it's not a big deal to go ahead and do a little bit in your head. So why I'm saying that is, okay, this derivative right here, I feel like I can probably do that in my head. So this derivative is for two things. Remember, when you're adding up stuff, you take derivative one at a time. So derivative of x just becomes 1. That's easy. Now let's try to do this part in our head. So we've got derivative of natural log of sine of x. Okay, that's a chain rule. So chain rule says take the thing on the inside, take the derivative. Well, derivative of sine is cosine times, take the thing on the outside, natural log, take its derivative. Remember, derivative of natural log is 1 over, and then you plug back in the thing that was on the inside. Okay, so there we go. So at this point, now we've pretty much done this derivative here. So let's go ahead and do a little bit of cleanup. At this point, probably what I would say is, how about if we said, so we have cosine over sine. You may remember that that's cotangent. If you'd like to do it that way, you can do it that way. I don't really think one way is any better than the other. But at this point, we've actually done all the hard work. We can slowly start taking what we got and plugging it back into the previous steps, and then we're going to be done with this long problem. So let's go ahead and do that. Let's take what we just got and plug it back in for the derivative of sine of x plus natural log of sine x. Okay, so we just took this derivative, right? That's what we were doing on our scratch paper, and we got 1 plus cosine x over sine x, all of that, times cosine of x plus ln of sine x. Okay. And let's go ahead and keep copying down the rest. So times 5 sine of x plus ln of sine x, all of this to the fourth power. Okay, again, remember, this is also scratch paper. This is also what we needed for the previous step. So let's go ahead and take this and plug it back into the previous step. So what we see right here is that we just computed the derivative of that big ugly part there. So let's go ahead and start writing it down here. So this becomes, of course, the cosine stays like it was. And what do we get for the next part? We got 1 plus cosine x over sine x times cosine of x plus ln of sine x. All of that times 5 sine of x plus ln of x of sine x. I'm laughing because just like you, I know this is so crazy. Okay, that's that first part there. Now this is going to be one big fraction, but just bear with me here. So we'll go ahead and do minus and then copying down the rest. Let's go ahead and do one thing to save ourselves a little bit of time as I'm copying this here. So the next we've got derivative of cosine. Well, derivative of cosine is negative sine. So we'll go ahead and put the sine here, and then the negative, I'm going to put it out front with this negative, and a negative turns into a positive. There we go. Okay, all of this divided by what's on the bottom. And we're done. There we go. There is our problem. So I know that's obviously so long, and you look at that and say that some people might think that's totally ridiculous. But again, what your test... Okay, so that's our problem. So I know you may look at this and say, this is so ridiculous, this is so long. But really, again, what they're testing is not about, can you take the derivative of sine to the fifth of x plus ln? That's not important. What they want to see is, can the student work slowly and carefully through this problem? And that's what we've done, right? We wrote out the problem, then we wrote out, okay, if we took the quotient rule, what would the steps be we're doing? And then we just use our scratch paper to slowly eat away at those derivatives. And that's the way you have to approach these problems. Otherwise, you're always going to make little mistakes. So with that, I hope you found this helpful. Go ahead and leave a like or a comment below if there's something you want me to cover, and I'll be sure to get to that. All right, thanks everyone, and have a good one.